Hi, welcome to the Bonds workshop. In this workshop, we will be discussing Dapp Architecture, how a Web3 application looks like, and how we can deploy smart contracts on the Bonds platform to any EVM based chains. The deployment demo would be a UI walkthrough, as we plan to have another workshop with a detailed step by step guide on how to deploy smart contracts to any EVM based chains. My name is Trust Onyekwere. I'm a blockchain solutions architect and I lead the DevRel team at Bonds, simplifying how developers build dApps. We'll take a look at blockchain technology, which is, of course, one of the buzzing tech language, or basically call it a tech buzz in the recent era. We would be looking at the blockchain technology, the use cases, and benefits. Of course, as developers, as builders in the Web3 space, we're familiar with this, but to go through them once again together to really appreciate the value that the blockchain technology is bringing and the innovations that it can inspire within the tech space. Throughout this talk, we'll take a look at from the benefits of the blockchain, and then we'll dive deep into how to structure and compare a Web2 application with that of an architecture diagram design of a Web3 application. And then we'll compare them together and then see the differences and how all developers and all builders can begin to take a look at building blockchain applications a little more differently. That can also help everyone else to begin to build application faster. And lastly, we'll talk about briefly about the bonds ecosystem and how it simplifies and reduces time and friction that blockchain developers, the engineers, for them to build dApps very quickly and easily. Before we proceed, mainly we'll talk about a very brief history about the whole blockchain and Web3 space. We're familiar that Web 1.0 became from 1990s, 2004, which was read only. And then there was an upgrade. Web 2, yes, came and it had not just read only features, but we could read and we could write. And that was from 2004 down to present. But then there's now a slight upgrade to Web 2, which is Web 3, which includes read, write, and own. So we could read, we could also contribute to the space. And of course, we can also own the content as definitely as we see in different other use cases from the blockchain space. So this is one of the favorite statements that I kind of coined up, but then it makes sense if you take a look at it from one angle. Web 3 is Web 2, but Web 2 is not Web 3. So basically, it means that we can find some elements of Web 2 in Web 3, but we can't find elements of Web 2 in Web 3. What does that mean? Yes, in Web 2, we can read, we can write, but in Web 2, we can't own. And so you cannot find elements of Web 3 in Web 2. So that is goes to show that if you're already a builder in Web 2 space, it is a lot easier for you to also build on Web 3 space. It's not that rough or that rigid as some think. Just understand that Web 3 is an upgrade to Web 2 and that Web 3 is Web 2 in a way because you can find elements of Web 2 and Web 3. And so if you're already a Web 2 builder, you can definitely jump into the Web 3 space to build. As we take a look at the differences in diagram, differences in architecture of both Web 3 and Web 2, and then that definitely would help you see better and how you can definitely walk around that. So, what makes a Web3 app? For context, we'll be interchanging DAB and Web3 in the same phrase because they definitely mean the same thing. So, DAB means decentralized application. Web3 is also Web3 app definitely means an app that is decentralized. So, it definitely means the same thing. So, DAB, Web3 app all mean the same in this workshop. How many of us are familiar with Medium? And so, if you are familiar with Medium, is a mini blogging platform. It was a micro at the time, but now it's more like a very big blogging as a service platform for people to easily write articles and share their ideas. It's on the Web2 space. And so, our comparison would be on Medium. We'll take a look at what makes Medium Medium in Web2 and what could make Medium Medium in Web3. The first is Medium for Web 2. As we know, it is a blogging platform. And first, there has to be where we can store data, where we can store all the articles, user logins, data all around for the users who are reading, users who are going to write as well. And second, there has to be a backend code, either written in Java, JavaScript, or Python that has to define the business logic. So Medium has a partner program where they pay authors to write, not to write, they pay authors per reading. So you write and then people who read, they calculate your pay, your earnings and share with you. So there's a system behind that logic. When people will share articles, people will see the article and they clap for you and they share and give you comment. That's business logic. So what happens at the back end? So of course we need a place to write the back end code about that too. When you write a new blog, when you delete a new blog, all of those things can be captured on the back end. And lastly, we need a front end. So front end code defines the UI logic, what people get to see, how do the site look like, what color we adding, how can others you interact with. So basically all of those things. Now three of those things, three of this make up Medium. And so this is the basic architecture of Medium or basically any other blogging platform. There is where you store the data, there's a back end for the logic. There's a front end to for the UI logic where you get to see what's happening. And so you write JavaScript, HTML, CSS for the back end, Node.js, Python, Java, Go, etc. And there's a web server where all of those things live. And then the browser calls them to display them, all happening on the internet. So if you're already a Web2 builder, this is will definitely look familiar to you because it simulates a day-to-day diagram for all of the applications you build, all follow similar patterns. You store data one place, you call the data, you display the back end, and then it definitely shows on the front end. All of those things can be intertwined, or there could be an API that connects this and this together. This basically shows all around how it looks like to build a Web2 medium. Now, how would a Web3 medium look like? Well, let's take a look. I mean, for one, the front end will stay the same. We still need to see something. We still need to see colors. We need to interact with something. The UI logic will stay the same, with some exceptions, of course. We'll take a look at those exceptions later. And then when there is no centralized web server. So things begin to change at the back end. Unlike the medium front end where we have a centralized web server. In this case, we don't have any of those things. And so that is where things begin to change. And then, of course, smart contracts. It used to define the business logic and applications deployed on state machines. So take a look at that as we proceed in this workshop. So you see in this diagram, it is a mini diagram of the Web3 version of Medium. The front end stays the same, but things begin to change at the back end. You have smart contracts hosting the business logic, and they are being run and deployed on the EVM machine, or sorry, EVM, which is Ethereum virtual machines. And then data are stored in blocks on Ethereum blockchain. So this could be. So of course you can decide to use any EVM based chain. So it could be Polygon, it could be BSC, it could be Celo. Of course, this hackathon is designed to run on Celo, and so of course Celo is EVM based right now, and so it would be run on the same EVM chain as well. And so smart contracts replacing the logic, and then the logic is being run on EVM chain and EVM EV machine, the EVM virtual machine, and then the data is being stored on the block and the blockchain, all of those things begin to change. And so if you're a Web2 builder, it goes to show that your front end stays the same. And so if you're already a front end developer on the Web2 side, it's fine. You can keep your skills, but then you learn a little bit more about the back end, which is smart contract, how you can interact with them. If you're a back end developer on the Web2 space, that's fine. You get to show that you need to learn extra on how you can begin to build smart contracts to power the back end of the Web3 or Dapp. How does a front end communicate with smart contracts on Ethereum? So there you've seen that yes, the front end stays the same, but we still need to interact with the back end. So how can we communicate with smart contracts on Ethereum? We know ordinary in Web2 space is going to be APIs and a lot of things going on. Is it the same on Web3 space? Well, so this diagram shows a little more advanced, not really advanced, but little bit more complete of what it's going to look like if you have like a medium version in Web3 space. There is a front end. Now there's a back end. Now there are extra things attached to it. So the question now is how can the front end communicate with the back end with smart contracts? Now you see that in the middle, the providers. What are the node providers? Well, remember, if you don't know, then it's good to know now that Ethereum is a decentralized network. There's nodes in the network scattered around. So every node in Ethereum network keeps a copy of all states of the EVM, including the code, the data, all in with every smart contract. So if you want to interact with the smart contracts at the back end, we need a node provider. So every node can broadcast a request for a transaction to be executed on the EVM. So we need a node provider to send those requests to the front end and back. There are two ways to broadcast a new transaction. The first is you can set up your own node which runs on Ethereum blockchain software, or you can use third-party node providers like you see on the screen, Ethereum, Alchemy, and QuickNode. If you want to use the first option of building your own node to run Ethereum blockchain, of course, it would be heavy to do that. But if you use a third party provider, you don't have to deal with all of the headaches of running a full node yourself and all. Setting up the Ethereum node on your own can take days. There are a lot of sync. It could take even about a more broad width and storage that a typical laptop can handle. And so there's quite a whole lot to do that. So it's more better and effective if you use third-party providers already taking up the heat away from you. The options, they could be Alchemy, Ethereum, QuickNote, MetaMask too, serves too as a provider and a signer. We'll talk about signers much later. So the nodes that you connect with, if you choose any of these options, need to interact with the blockchain, whether you set them up yourself or use these third-party providers that are called providers. Then they will send a request on your behalf, and then you can connect the response of the request to your front end. And so every Ethereum client, which is a provider, implements a JSON RPC specification. So this basically ensures that there's a uniform request that when the front end application wants to interact with the blockchain, it all does the same time, and of course, it's uniform and also easier to get it to on the front end. So once you connect to the blockchain through a provider, you can read the stored data, the state of the data in the blockchain. Now, let's move over to MetaMask. You need MetaMask to sign transactions. Now, once you've connected through these providers, if you want to remember, then again, it's good to know that once you want to read from the blockchain, it's free. But once you want to write or change the state of the blockchain, you have to sign transactions. That's where signer comes in. And the most popular signer is MetaMask, right? And so you need to sign. That is where MetaMask comes in. So look, going back to the Medium use case, imagine that we have a DAB that lets users read or publish or post blog posts to the blockchain. You must have a button on the front end that allows anyone to query for the posts written by a particular user. That's called reading from the blockchain. And so the user doesn't need to sign any transactions. But when you want to publish a new post onto the chain, which is changing the state of that blockchain, you're adding new posts, then you have to sign transaction using your private key. Then that's when you can now be able to publish the article on the blockchain. So signing the transactions typically is where MetaMask come in, which helps you to sign. MetaMask is a tool that makes it easier for applications to handle key management and transaction signing. It serves also as a provider, as we saw that previously there. But the main use case, most people use it as a signer, but it can also be used as a provider as well, alongside Alchemy, Infura, and then QuickNode. Now we have IPFS storage. So if you intend right to store your data on a decentralized platform, that's where IPFS or SWAM comes in. So this is on chain. Um, for this to happen, let's also get back some knowledge, because when we want to on Ethereum, the user pays every time they add new data to the blockchain. That's because adding a state to a blockchain, as we say, costs for the nodes that are maintaining the state machine. So they have, like, get some gas fees to control those maintenance. Asking users to pay extra for using their DApp every time they want to publish a new transaction or they want to publish a new post, as I was saying in Medium, is not the best user experience. So one way to beat this is to use a decentralized off-chain storage solution like IPFS or SWAM. IPFS stands for IPFS is hold on. So IPFS stands for Interplanetary File System, and so it's a distributed file system for storing and accessing data. So rather than storing data in a centralized database, which costs more, each time they want to sign, they have to pay. The IPFS system distributes and stores the data in peer-to-peer networks, which makes it easier and easy for you to retrieve it where you need to retrieve when you need to retrieve it. So IPFS also has a layer called Filecoin. If you're familiar with Filecoin, this provides nodes around the world to store and retrieve this data. So IPFS generally has different tools that really helps to simplify and make it easier to store data off chain but still connected to the blockchain. Swarm too, as you can see in the diagram, Swarm is also similar in that it is a distributed or decentralized storage network. But as a difference, Wi-Fi coin, which is a layer of IPFS, is a separate system. Swarm's incentive system is built around and enforced through smart contract on Ethereum for storage and retrieving data. So for now, with IPFS or Swarm, our application architecture will look like as we see it here. And so IPFS or Swarm is definitely a more preferred option to go with, which IPFS also has a layer called Filecoin. So this is how it looks like. And so if you're going to build a medium version medium version in Web3, this is how the diagram will look like. As a front end, as a back end, the smart contracts, the logic, as a node provider that interacts with the smart contracts, and back and forth from front end to the smart contract, the back end. You sign transactions each time you want to put in or change the state of the blockchain, and you store data on a distributed file system, IPFS, or SWAM. And that definitely looks like this. Now, remember too that not all of your dApps are going to be 100% decentralized. What do I mean? This on the screen is 100% decentralized. But you can also choose to replace this diagram, replace the IPFS or SWAM database with your maybe cloud storage. Could be AWS, it could be Microsoft Azure, or it could even be GCP, and that would make it hybrid. So it is partly centralized and partly decentralized. So using both Web 2 and 3 and Web 3 technologies, but you can also decide to make it 100%, decentralized. So that's left for you, but all will still perform the same way. And of course, looking at a use case you want to use, I would definitely help you to make it better, the decision. All of these things can be a lot to take in, especially if you're newly coming to Web3. Even those who are, a year or some months old in Web3 too can be confused in a way. But basically, take some time to take a look at this. Ideas can flow for the hackathons, but it's good to have a better design architecture for that. Helps you know what you need, what kind of smart contracts do you need, where do you want to deploy it, which of the, I mean, Celo has quite impressive low gas fee as compared to others, and that would definitely help you to take a look at how to utilize that. Of course, take a look at what Celo also has in its tools to simplify the way that you also build and use case you have in mind. This is an even more even more um, complete diagram architecture of how the entire medium will look like with more features added. We have the graph over there. The graph there. So basically, we have smart contract events. Whenever you use a library like Web3.js or Ethers.js to listen for smart contract events, you can listen to specific events and specify a callback time every time the event is fired. Of course, smart contract have events. If you have a smart contract that sends a continuous payment stream from person A to person B every block, then you can emit events every time a new payment is made to person B or a second person. Front end code can listen to events being fired each time a smart contract event is being executed. But then it can be difficult to really keep pace with these events. So if you take a look at the smart contract events we just described, it has some limitations. For instance, if you want to deploy a smart contract and you later realize that, oh, as an event you need to emit, they did not include originally. How? I mean, we know that smart contracts can be edited, so you have to redeploy a new smart contract with that event and data. Moreover, using callbacks to handle various UI logics, can get complex very quickly. That is where the graph comes in. See the graph there? So the graph is an off-chain indexing solution that makes it easier to query data on the Ethereum blockchain. The graph allows you to define which smart contracts to index, which events and functions to listen to, how to transform those incoming events into entities that your front end logic can carry whenever an API is being consumed. So it uses GraphQL as a query language, which many front end developers, engineers are familiar with because of how low expressive it is compared to normal traditional REST APIs. So by indexing this blockchain data, the graph lets us query this on-chain data in our application with low latency, and then you can definitely heavily begin to go back and forth within this index, which it will not be possible if we do not use the graph. And of course, we can miss some events and we have to deploy the smart contract again. So that's how this is going to look like, and they have Polygon for scaling. I mean, many of us have had that Ethereum doesn't scale, at least not yet. So that is where Polygon and most of the layer twos come in to scale that. Right? I mean, Celo 2 can also be helpful in those as well. So this is the complete diagram of a thorough Web3 version of Medium. And once again, it can be a lot to take in, no doubt. And that's fine, right? So with time, and of course, as you begin to document your ideas and how to proceed, it's easier for you to know how to move around them from back and forth. So bonds simplifies this whole development process. We've seen there's quite a lot to take in. There's so many components flying here and there. Bonds provides already made smart contracts models across different use cases, DeFi, NFTs, DAOs, tokens, and RC20 tokens and the rest of them. We're adding more NFT standards and lots more use cases as we go. So, as a front-end developer, you may not necessarily have to write smart contracts yourself. Simply look for one that fits your use case, deploy to Celo or any EVM-based chains, and you're good to go. Copy the. I will take a look at that, briefly, and they can interact with that on your front end. If you're already a smart contract developer, you can, of course, take a look at what we have. It did them on your VS Code, copy the code they did, redeploy. So it basically simplifies the Dapp development process and helps you manage your smart contract easily. Recently, we just launched the Cypher, which is an AI tool that generates smart contract documentation from any block explorer. So once you've deployed a smart contract, you can easily generate the documentation using the Cypher, thorough documentation, how to document functions, code itself, and really like simplify and streamline how developers can build their dApps during the hackathon, post hackathon as well. So now we'll take a very quick look at bonds and the overall how bonds work, and then we would return and see how for next workshop, we'll definitely dive deeper into hands-on how to really do this from the bonds. But now we'll just give like a very brief overview of how this work. So we'll go to bonds, bonds.dev. So that's the URL, bonds.dev. And of course, as you can see, smart ecosystem for smart contracts, find, deploy, and manage reviewed contracts easily. And we had over 8,500 deployments, around 100 supported chains or EVMs. And then we have the Cypher, which I just described earlier. And the Bonds ecosystem definitely is a game changer for how you can build Web3 applications. And of course, EVM based change, Celo, BSC, Polygon, Avalanche, Optimism, and many of those things. Yeah. So let's we have the documentation, the Explorer. Explorer basically takes you to where you can take quite a whole look at different smart contracts templates that exist and how you can definitely begin to walk around them and deploy, and most of those things come in that particular angle. Then tutorials takes you to our blog where you can see different articles and all of those things combined. So let's log it. We'll take more deeply into this for the next hackathon, for the next workshop, and how to go around this. So let's take a look at login to. Of course, the Cipher has a Chrome extension. So the Chrome extension for the Cipher, and easily have the handy on your browser whenever you are visiting any EVM based block explorer. You can quickly generate smart contract documentation from there as well. Okay, so let us log in. Just show you briefly the dashboard that we currently have there. Okay, so I'm clicking on login. All right, so I am logged in now. I'll make it bigger. Yes. So if you're not already have an account, you need to create an account or sign in or sign up, depending on what level of user registration phase you are. And then these are like the dApps I have tried to deploy and try to create for tutorials and for personal use as well. You can see ICO dApps, Flash Loan, is Diamond My Token. I tried to do that and NFT maintain all of those things, payment splitter for payroll, testing in the Web3 space, all of those smart contracts were deployed using templates existing here already. And the first thing to do, of course, is to connect your MetaMask. So that will be much of a showcase right now, just showing you the UI of all of those things. So it's already connected to Cello. And then click on create Dapp. So creating create Dapp takes you to this where you can simply input. So I'll just say payment splitter. Payment splitter smart contract allows you to send payments, splitting the percentage, just like a payroll work. So you can use it to build a payroll system on the blockchain for whatever use case you want to use that for. Also, clicking next takes you to select network. There are supported automatic networks you can quickly deploy to. We have a Bitron, we have a Scroll, yes, Scroll testnet, yeah. We have Asta, Polygon, BSC. Letting each of these automatically add their chain ID, but you can bring in your own chain. So you imagine, or when you do not have any, there is no blockchain explorer listed here, but you want to deploy is EVM based chain. You can quickly add it here and deploy. But since it's a solo based hackathon, there's solo here and there's solo here, so you're good to go. And then you click next, and then I'm going to search. So you can search for displacement splitter. That's what I'm looking for. You can always search. There's so many templates here, right here. So you can, these are Bunzz models built by the Bunzz team, and they're prepared templates in box and all of those things. And then so you quickly, explore this. So clicking on this takes us to the documentation page for this particular smart contracts model. And so it's a payment splitter. So this takes us there. You can see how to use module parameters, functions, events, code, all of those things. You can quickly move around there, module templates, functions, events, code, and payment splitter. You can of course take a look at the code. So we're definitely adding more features for you to edit the code via the Bunzz CLI, which connects to the cipher. You can simply copy this and paste on your VS Code manually for now while we update that particular feature, and of course deploy, see the code you want, and edit a few things you want to add, and yeah, you can deploy to any of the, of course it's Cello, so you can deploy the Cello and then connect to MetaMask, and then you're good to go. So yeah, we'll definitely talk about this more during the next workshop, and how to deploy to Cello easily from Bonds. And yeah, that's basically that. Repository is basically you trying to bring in your own smart contract. So imagine you have your own smart contract that's not really already on the Bonds smart contract hub. You can simply import it and manage it and deploy on the Bonds and manage your smart contract using GUI. Yeah, that basically works in the same way. I think I can. Okay, let me basically do that. I think I have to deploy this. Yeah. So let me just show briefly how this works. We'll go deeper into that, the live section. Okay. All right. So let me go back. I think I've, yeah. So we had payment splitter. Yes. So we chose this, and then we took payment splitter. Yes. Add. Nothing more to add to that. So in case you want to combine two or more smart contracts, you can do that, but we just need this. So deploy, it loads the deployment phase, and then MetaMask pops up for me to sign transactions, which is taking a while. So let's hold on. Yeah, and so I've done that. And so it's completed, so it's done, so it's deployed. You can check this on the Cello Block Explorer, and then you can copy the ABI smart contract address. We'll take a look at that much later. Manage your smart contracts allows you to manage it via UI, rather than the CLI part of things. You can verify and do most of the things you want to do basically on here. So we'll definitely dive deeper into all of these features. You can see monitoring, Explorer, risk generator, and all of those things. Yeah. So all around, we really do um, really do expect and hope that all of these things we've mentioned right now, especially, okay, not this, sorry, I must have taken a look at it bad, the wrong one. Yeah, so of course you learn by building and you build by learning, and so you just have to start building using any of these features, and of course you can see what you begin to deploy and build on the hackathon, and we're so excited for the solutions and ideas we've seen, and hopefully definitely get started. So yeah, thank you so much for spending time through the recording down to this place, and of course we'll have a more live section in the coming days where you get to ask your questions and try new things, and definitely get to assist you from there. Thank you very much. Any other questions, of course, you can always ask me at on Twitter at IMTJ, of course on Discord where the hackathon mentorship and guidance will be done officially over there. Thank you and do have a very good day.